Introduction. The second law of thermodynamics explains the heat flows naturally from a hot object to a cold object, causing an increase in entropy and making the process irreversible. In this project, heat transfer occurs from hot to cold aluminum balls, demonstrating how thermal energy moves toward equilibrium. Temperature changes are recorded over time to track the cooling and warming rates of the blocks. Entropy change is calculated to analyze irreversibility, providing mathematical proof that the total disorder of the system has increased. Objective: to determine the change in entropy during the heat transfer between two aluminum blocks at different temperatures, and to verify the heat flows from a hot region to a cold region in accordance with the second law of thermodynamics. shows how the temperature of cool aluminium block increases while the hot block decreases with time. At the beginning, the temperature difference is large, so heat transfer happens quickly. As time passes, the rate of heat transfer slows down until both blocks reach nearly the same temperature at about 36.3 Celsius. This point is called thermal equilibrium, where there is no more net heat transfer between the two blocks. The experiment demonstrates the second law of thermodynamics because heat flows naturally from the hot block to the cool block and cannot reverse by itself. The heat lost by the hot block is approximately equal to the heat gained by the cool block. Although some energy is lost to the surroundings due to imperfect insulation, this behavior is similar to real-life situations such as hot coffee cooling in a room. As heat is transferred, entropy increases because the energy becomes more spread out and less concentrated.
Why does heat transfer from hot to cold? Heat is a form of energy. When energy is added to atoms, they begin to move more rapidly. Think of it like kinetic energy. When you push a ball or add energy to it, it rolls. This means that the more motion atoms have, the hotter they feel to the touch. Back to the ball example. If you have a stationary ball and you impact it with another ball, the energy of the rolling ball is transferred into the stationary ball, causing it to move. You would say that the stationary ball absorbed the faster ball's energy. It wouldn't be right or sound right to say that the stationary ball transferred its stationary state to the rolling ball. The same is said about atoms transferring energy. The fast-moving atoms impact slow-moving atoms, transferring their kinetic energy. Therefore, to say heat transfers from hot to cold really means that energy is transferred from fast-moving atoms to slow-moving atoms.
In conclusion, this experiment successfully demonstrated controlled heat transfer between two objects. The procedures and measurements were carried out effectively, allowing clear observation of energy exchange and system behavior. Overall, the setup provided valuable practical insight into thermal interaction and was appreciated for studying fundamental thermodynamic principles.